Hi and welcome back to my channel. I'm Jadi and this is the Down Under CTF. Very nice CTF, very nice challenges, only 3 hours remaining and I've thought maybe it's better to stop playing. I was playing the blockchain section, we are doing very good, although nobody solved any crypto. Because sometimes I solve cryptos, but today I prefer to practice the blockchain. Blockchain is a very nice section in these challenges. In most cases, you have a blockchain, you have to try to solve the challenges. And challenges are not that tricky in most cases, although I was not able to solve immutable yet. I will try a little bit more, but I've thought it's good to show you how these challenges work. We will focus on 8-5-4-5 challenge. It's a beginner level. As you can see, it's a beginner level. Although it's beginner level, only 174 people solved it at the moment. Still not a high number. The reason I'm showing you this and I'm suggesting you to practice them by yourself is this is something which is happening in real life. If you know how to solve this challenge, you might have a work in the crypto industry. In most of these challenges, we have an Ethereum blockchain and we have some questions to find some data from here. Sometimes you need to know some Solidity language if you are working with a smart contract like these cases, and you should know a library like web3, for example, under Python to communicate with this. What is the challenge? This is a warm-up. Let's get you set up and make sure you can connect to the blockchain infra. Your challenge is to ensure that the isSolve function returns true. This is the program we can download. I've downloaded it and I will start a challenge. I will create an instance. The instance will be created here and will remain active for 1 hour. We have to wait a little bit because this is bringing up a Ethereum blockchain. What we need to do, we have a smart contract. I've just downloaded it. We will have a look to it. So we have an Ethereum blockchain and a smart contract is here. There is a function is solved and this should return true. Why I'm showing you this one and not the more advanced ones is we are not going to show you how to solve tricky challenges, how to read everything, how to understand bugs in the smart contract and these kind of stuff. I want to show you how to start working with blockchain using web3 libraries and how to very basically read or call different smart contracts in Solidity language. This is so cool because there are lots of companies who will hire you even if you know not the basics, but intermediate level of these things, because there are very few people knowing this. And even on these CTFs that hackers play, there aren't many people who are trying to solve this because this is new. Very few people are there. So if you know it, industry is looking for you. This is a good start to see what should be done. But let me open a terminal. Here we will work. Let's have a look at the Solidity Smart Contract we just downloaded. Okay. This is a smart contract, very easy to read. Even if you have never seen Solidity, this will be kind of obvious. We have a contract. It's called 8545. Okay, no problem. There is a string here which is private. It is called use this. And there is a public boolean which is called you solved it. It's false. Starts with false. We have a constructor. We have a function, read the string here. We have a function, solve the challenge. We have a function, is solved. The question asked us, is solved, should return true. At the moment, if you call is solved, it will return you solved it. And you solved it is false. We have to make this true. We have one function which is solve the challenge. It gets a parameter called answer and change the value of you solved it, which is false in the beginning, based on if the specific hash of this, same hash here, so not much usage, use this equals answer. So if you know what is use this and send it to this function as a parameter, and these two are equal, you solved it will become true. And then the is solved will return back true. But how can we know what is use this? There is another function. Read the string here. If you call this, it will return back use this. So very easy. We have a blockchain. This smart contract is running on it somewhere with an address. We need to call is solved. It will return back false. Then we need to call read the string here. It will return back the value of use this. Then we have to call solve the challenge and send whatever we got as an answer, because it is equal to use this. The value of you solved it will become true. Then if we call is solved, the value will be true. But how this use this gets some value in the constructor. When the smart contract is deployed, it is deployed by a variable, some string. We pass it some string when we are starting this smart contract. And it sets the use this to some string. So these are the steps. When this is deployed on the blockchain, it is called by a string. Use this will have that string. We will call read the string here and we get that. Then we call solve the challenge by passing whatever we got from here. These are equal, so this will become true. So this is solved, will return back true, and the challenge is solved. Very, very easy. This is just to check if you can interact with a smart contract on a blockchain. So very, very good for us to learn this stuff. And as I've told you, if you search the job forums, there are lots and lots of jobs for people who can write smart contracts. And you can see Solidity is an easy language, very easy language. Although there are some tricks, and it's very, very important to understand what you're doing. If you say, I'm a Solidity programmer, you cannot just copy paste anything from internet. You can copy, but you have to completely understand before pasting it in your memory. Because it's not in your front of you, you have not pasted it yet. Because there are contracts that people create, upload as a sample contract. You just search them, you use them, and there are backdoors in it. Anyway, let's see if this is up. Oh. Okay, this is up. We requested an instance of an Ethereum blockchain. It is up. As you can see, it shows some data. It is deployed. You have one Ethereum in it. This is a test. So there is a wallet address, which is the color address always. You have the private key. No one should see your private key in any real world scenario. You have the contract address, where in the blockchain the contract is deployed, so you can reach this contract. Block time is 0. URL of this, and the chain ID is here. Okay. These are all needed. And you have the source of the smart contract here. Please note, in real life, if you are hacking the blockchain, you don't have the data of the smart contract. You don't have the source of the smart contract. You have something which is called ABI. This is contract binary interface, maybe application binary interface. I don't know what is it. But you have the ABI. ABI is a JSON which tells if you want to call this function, you have this function. If you want to call it, you should provide no input, and this will return back an string. ABI is this. We need to create ABI from this file. But let's start having all of these in a Python program. I'm going to use, so here I'm introducing two things. Solidity is a language in which you can write your smart contracts on Ethereum blockchain, and web3 is a very, very nice library to interact with the web3, with blockchains, especially Ethereum we will use. I'm using web3 under Python, so I have installed web3. So I will enter the IPython. Here I will have the IPython running. IPython is easier because you can write commands, you can go up, down, run them in bunches instead of having a huge program and trying to run it and see what happens. Here you can go step by step. You can go a equals 5. Okay, done. What is a? Print a plus 5. B equals a to 2. B. It's very much easier. So what we are going to do, as I've told you, I'm going to first create some variables for all of these. So my wallet, which is also color, this is my address, my private key, PK is my private key, my contract address, because when you want to connect to the contracts, you have to say, I want to connect to this one. My block time is 0. This is the concept which is nonce. Each time you have to increase 1. And RPC URL is this one. If I want to interact with this this blockchain, I have to use this address, and this is the chain ID. I think chain ID is a number. Maybe there is no difference here. So as I've told you, we are using web3 Python libraries. These are the ones. web3 Python. If you are new to it, you can go with quick start. It will tell you how to install it. Install it using pip. Then you can import different things. Also, you have one Ethereum tester provider, which you can use as a test if you don't have a chain to connect to. There are some local providers. We have one HTTP provider which connects to a HTTP address. This is what I'm going to use. So let's go for it. What we had, I will say web3 equals web3. I have not imported it. I will do right now. URL. Okay, this doesn't work. I will say from web3 import web3. Now I can connect to this. If I write URL correctly once. Now I have a web3 variable. I can say web3 on IPython. You can just double tap and it will show you what possibilities you have. For example, API. This is the version. Cool. I can say is connected. Yes, we are connected to our blockchain. I will make it a little bit larger to make it easier for you. So what I did was imported this, gave it the URL and said, okay, please web3 connect to HTTP provider on this address. I had the URL from the configurations and I checked if I am connected to this. Where is my is connected? And you saw it. When you are connecting to the blockchain, you will get all this data from here. Although if it's not your own source, you won't get this in most cases. Again, although many of the coins we see, smart contracts we see, are forks from very, very, very famous sources. So you can have the source and functions and everything. So I've connected to this address. Now I need to connect to my specific smart contract in this address. Let's go for it. Let's have this here. And also here you saw I connected like this. You can connect like this. Have a quick look on this documentation. For example, I'm working with the contracts. Where are the contracts? It's here. It says when you want to connect to the contract, this is how you deploy a contract. There are properties for the contracts, for example, the ABI of the contract, constructor of a contract, and everything you need is here. When calling contracts, again, you have two different methods. I will show you later. Let's connect to the contract first. You should say I have a contract. It equals to web3 library. I'm working with Ethereum. I have a new contract. Contract address is this one. And you need the ABI. I don't have the ABI, so I will get an error. Let's get the ABI. We have the source, so we can generate ABI from the source. I can say Solana compiler downloads Solana. I can compile it, or I can ask for the ABI. This is the ABI. ABI is a JSON in an array or something, which tells you how to interact with this specific contract. So they won't give you the source of the contract in most cases, but they will provide you the ABI. For example, it says if you want to check this, if you want to call this function, which names is solve the challenge, there is no output, but you should give an input, which is internal type string. The name is answer and type is string. If you are calling the function, I'm looking for is solved. For example, whatever you have here will work. For example, the function name is solved. Its input is nothing. Its output is internal type Boolean. The name is nothing. It doesn't have a name, but the type is Boolean. It will return back a Boolean variable. So this is how you will know how to interact with this. I will copy this. I'll come here. I will say ABI equals this. Now I can connect to my contract. I'll say, okay, I had the web3 connection. Now I'm connecting to an contract in that web3. Contract equals web3 ETH contract. This is the address. This is the API. So now I'm connected. You can see contract functions. There are some functions. I can say for f in contract functions, print f. You have the name of all the functions. It comes from this API. And you can start calling them. Even I can do very easily. I can say from contract, from functions, there is one is solved function. Okay, this is just a function. I have to call it. This one doesn't do anything with the smart contract. We will just read some data. No change in the blocks because it just goes to this function and it returns this. No change on the state of the data or the blocks. So you just call it. But if I wanted to run something which changes data here, for example, this one changes the data. I have to say, who am I? So I should take more step than call. I have to say, I want to build a transaction. Then I have to, this will give me a JSON with the transaction data I'm going to run. Then I have to sign it cryptographically with my private key. So the system will be sure that this is coming from this wallet. Then I have to send the request to the blockchain. It will give me back a hash. And later I can say, okay, what happened to my hash? when I'm sending this, this will be started to run on the Ethereum virtual machine and will provide me a hash as a token. I will go back with the same hash and say, okay, what was the answer? It will give me back the answer. But first we need to know the value of use this, which is easy. I can go with read the string here. So let's call that one. I will say contract functions, read the string here, call. I can connect to the blockchain. This was the secret. This is what was used when constructing the smart contract, and use this equals I can connect to the blockchain. Now we are connected to our blockchain, sure, and we are calling functions which return value without any change. Now it's time to do more. So I will say contract functions, I need solve the challenge. Solve the challenge and pass this variable. I can not do a call here. It won't return anything because this is asking some change in the data. I have to sign it and I have to spend some money because the blockchain is doing something for me. So, as I've told you, the method is build transactions. If I'm not wrong, I might be. Build transaction, get some data. One is from who is sending this. I will give it my color, which is my wallet address. And also I should send another data, which was a nonce. Nonce is like, I want to send you one, give me a slot. It was 0 in the beginning and nobody is using the same blockchain, so I can send 0. Otherwise I had to send 1, or the correct method was calling a function which return back a nonce. An error. Okay. This says the field extra data is 97 bytes, but should be 32. It is quite likely that you are connected to a POA chain. Refer to this specific document for the solution. Very easy. We search for POA chains. It says, okay, if you have a POA chain, you need to send me this specific middleware from blah 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 blah. Ow. Okay, this is web3. So what we did was we said from web3 libraries import the POA middleware. It just told me to do so, and then add this middleware to my web3. So whenever I want to call web3, the data will go through this, and whatever magic needs to happen will happen. It was a direct thing here. And since I'm talking too much, if you want to get the nonce, you can say web3 ETH get transaction count. Okay, how many transactions we had there for my wallet? I believe. Yes, it will tell you 0. So you can send nonce 0. The correct way would be calling this, getting this, and putting this in our request, which is this one. So contract functions solve the challenge. I'm just creating the transaction. So let's save the result in this. Again, it didn't work. It says I need base fee per gas. I'm doing something. I need my gas money. So I can say gas price is 1. I'm okay with the gas price. Okay. It created this request. This is the equivalent of calling this function with this data. But this is not signed. Anyone can create this and just send it. I need to create a signed transaction. Again, I will say web3 ETH from the account, sign transaction, this transaction, and my private key is PK. This is why IPython is so cool. It's very easy to go and check whatever is needed. So I say I created this transaction, which is equivalent to calling this. And since anybody can just create this and use my wallet and say, okay, I want to call this, charge this wallet, I should sign it with my private key, which nobody has ever seen, except me, you, and whoever watching this video. So this is a test blockchain, so no problem. So now this is the signed, practically encrypted transaction. I can send this. This is the raw. Some bytes will be there. This is a raw transaction. I have to send this. So I will say, you remember what we are doing. We have the blockchain. We connected to it using web3. We connected to a contract with contract address as the color. So it's here. Then we said, I need a transaction on this function with this data. It gave me this. Then I created a signed version using my private key. Now I have to send this signed transaction to the blockchain, to that contract technically, get back a hash of this request. A bit later I can say, give me the answer back with this hash. This is like a token. It says, okay, have this hash, return back and I will give you an answer. I will go back, says, is my answer ready with this hash? And it says, okay, your answer is ready. The function is called. These are the results. This is what I'm doing. So now we have the signed transaction. We need to call it. I can say, for example, hash of signed transaction when going and returning back is web3 ETH send raw transaction. What is my transaction? Signed transaction, raw transaction. Nothing more. No need for private key, color, because everything is in this request. Now I have the hash of signed transaction. I just need to check the blockchain to see if the answer is ready. I will go with web3 ETH void for. I was playing this the whole day, so I have everything in memory, but you can read the docs, search how to call. And you remember we have two different calls. Normal call was for just reading. This signing, creating, everything, waiting for the hash is for when you're changing the state in the blockchain. Wait for this with this hash of signed transaction I just got. And the answer is ready. Status is 1. From this one, effective gas price is this one. Cumulative gas used is this one. So some funds are used, but I have called it. Let's check here. See, I used some money to do this. Cool. And now the value should be, if I go with contract, functions, is solved, call. Ow. Now it's true. Because we successfully created something, read this data, called this, so, and send it the answer we got from here. These were equal. Now this is true. This is true. So is solved is true. The last thing is just pushing, get the flag. This will check. Since that is true, I can get the flag. This was the basics of how you can interact with the Ethereum blockchain with a smart contract. This was not the basics. If you find a job about this, Every other thing you would do would be variations of the same thing. Understanding Solidity, sometimes writing Solidity, be super careful if you have to write something. Most of other challenges do have minor bugs in their Solidity. For example, something is not correctly checked. Something is, you can send a negative value. You can transfer something in negative and it will add to your funds and these kind of stuff. Anyway, hope you enjoyed it. For sure, the next step for you is going to the web3 PY or whatever language you want and do a quick start. There are different softwares. For example, if you search for the Solidity IDE, there are even, for example, this Remix, which is from ethereum.org, which lets you find the ABI much easier, call different functions. It has access to specific famous tokens and everything. So hope you enjoyed it and hope you continue learning. This is what I want. And I was super happy if you tell your friends. I have very little viewers. Not disappointing because I'm enjoying this, but that would give me more energy. Tell your friends and have fun and learn things and enjoy things. I was chatting.